Hello everyone. Let's continue our analysis of this small piece of circuit. So now we'll measure RCD and we'll calculate RCD and we'll try to match it. Already the measurement was done. Let's just quickly cross check that. So I go to the resistance measurement and then I'll try to measure RCD. So here I'm getting 55 kilo ohms. So let's reduce the range and then see with little bit more decimal point also. Okay, somewhere between 3 and 4. So let's go with 55.4. Okay. So this is the measured value, 55.4. Now what is the calculated value? So let's come to the calculation part. So let us calculate RCD. I believe that's what, yeah. So now to calculate RCD, if you again notice the circuit, we are interested in point C and D. Therefore, this branch will be kind of series connected, 220 and 330, which will be in turn connected in parallel with 820. Similarly, this 560 is also parallel with that, and then 100 is separate. Okay, so let's work it out. So the equivalent circuit after this will be a circuit like this, 100 kilo ohms at the top, and I have point D here, 68 kilo ohms here. Now one branch is 560, see other branch is 820, and the other branch is 330 series with 220, so it will be again 550. So already this calculation we had done in a earlier calculation, that is for the earlier case. Okay, so when we are calculating resistance between B and D, the same thing happened. 560, 820 and 550 came in parallel. So here also you can see 560, 820 and 550 coming in parallel. So therefore I'll directly jump this step and directly go up to here. 207.32 is the equivalent of these three in parallel. Okay, so let's go back here and leave this as 100K same, 68K same. This point is D and this point is, in this example, B, and here it is point C, which is also important because RCD is what we want to find. Now this one is the combination of these three in parallel, which came out to be 207.32. Okay. 207.32. Now because I'm interested in resistance between C and D, this two will become series and in parallel with 68. Okay, so this becomes like this. 207.32 plus 100 will be 307.32 kilo ohms, parallel with 68 kilo ohms, and this whole thing is now point C and point D. Okay. So from this I'll directly get the resistance RCD. Okay, so which is a parallel combination of these two. So again, to calculate that, let me get my calculator. So 307.32 multiplied by 68 divided by 68 plus 307.32. So I'm getting 55.68. I'll round it off 79 to 68. So 55.68 kilo ohms. Okay, so this is the calculated value. So let's compare it with the measured value, which we just sometime back we measured, which is 55.68 versus 55.4. So therefore it is almost matching. So in terms of percentage error, so 55.4, the measured value divided by the calculated value 55.68. So the ratio is 0.99, that is 99.49%. So if I subtract 1, so this is about the accuracy is about half a percent. Okay, so 0.5% is the accuracy of this, or error, not the accuracy, the error in the measurement. So again, as I said, as long as the error is below 1% or below 5%, it is good enough. So there it is. For this particular circuit that we were analyzing in this playlist, we have finished everything except this quantity, the calculation of RAD, which involves delta to star conversion. So we already discussed that in one of the earlier videos, the theory of, you know, what is the derivation of delta to star conversion. But in this case, I will copy the formula and I will show how the formula to be used, and we will work it out. Okay. So in the next video, let's tackle RAD, supposed to be 175. If you find these videos interesting, please like and share and subscribe to my channel. Thank you.